Oh, hello there. I was just attaching some of these cameras to these lovely telescopes that you see here. If you'd like to learn how to attach your smartphone or DSLR / mirrorless camera, or even a point and shoot camera or dedicated astronomy camera to various types of telescopes so that you too can take photos of space, then I invite you to come along this wondrous educational journey where together we will do all of that in this video. I'm Sarah Matthews, and as always, grab a snack if you would like to, of course, and let's jump into it. So this video comes at the request of some really awesome viewers of my moon photography with a DSLR YouTube video. In that video, we learn how to photograph the moon using a DSLR, as the name kind of suggests. But instead of using a telescope, we used a zoom camera lens. And that's what prompted me to ask if anyone would be interested in learning how to attach a camera to a telescope, and I did receive a lot of folks in favor of that, which is why I have made this video today. Just like camera lenses, telescopes are going to be great options for photographing space with. Why is this? Well, telescopes tend to have pretty large apertures, which means they can collect a lot of light, which means they reveal a lot of detail, which is a good thing when you are photographing the black abyss of space. Also, if you are looking for something with a lot of reach, say over 1300 millimeters of focal length, and at a reasonable cost, then a telescope is going to be a great option for you in that department. Now, this is by no means an exhaustive list of reasons why you should use a telescope to photograph space with. And it's also not me saying that you shouldn't use a camera lens to photograph space with. Really, which piece of equipment you would use over the other comes down to what your imaging goals are, and that should inform which piece of equipment you use, as well as what imaging techniques you use. And that's true for anything in astrophotography, and it's also true for what we're talking about today, which is why we're not just going to be covering one method for connecting a camera to a telescope. We are going to be covering 4 different methods for connecting a camera to a telescope. And this is because, depending on what kind of camera you are using, as well as the design of the telescope that you have, as well as what adapters or other pieces of equipment that you may or may not have available to you, and really just what you want to get out of your imaging session as far as the targets you want to photograph and the overall image quality, all of these factors are going to inform which method you should use. And so, with all that being said, I think we can now get into our first method. We have the first method, which is called afocal astrophotography. It's also sometimes referred to as afocal projection. Now, if you are a total beginner to everything astrophotography and are on a budget, then this method is for you. Also, if you are already a visual astronomer and have been wanting to make the leap into astrophotography, then look no more. This method has your back. And this is because afocal projection is a fairly straightforward method to do and doesn't require a whole lot of extra equipment outside of what you probably already have if you're watching this video. Why is this the case? Well, instead of using our human eye to observe what we would normally be observing through an eyepiece, there you have it. In its most simplest application, this is going to be great for taking quick shots or videos of bright targets like the moon or the planets. It is less ideal for taking photos of deep space objects like galaxies and nebulae because they're pretty dim, which means they're going to require more exposure time, and that requires some more advanced techniques and equipment. Now, it's not impossible. You can try imaging the Orion Nebula, which is pretty bright. You're just not going to be able to get the best results that you would be able to if you were using a different method, which we'll go over. Now, here's everything you're going to need. Oh my goodness, what is this? I just want to take a moment to thank all of my amazing subscribers and patrons over on my Patreon page. I really couldn't do any of this without you guys. It really does enable me to be able to create more content like this, so I am forever grateful. if you do want to support this channel and you're not already a subscriber, please consider becoming a subscriber. And if you'd also like to become a patron, I will link my Patreon down below for you to check out. And again, as always, just thank you so much. Y'all rock a lot. The first thing that we're going to need for afocal projection is a camera with a lens attached to it. So a smartphone like this, or a point and shoot camera. The next thing that we're going to need is a telescope, and any telescope design will work. So whether it's a refractor or a reflector like a Newtonian or Dobsonian, or a catadioptric design telescope like a Schmidt-Cassegrain, any telescope design will work, and that's one of the best things about the afocal projection method, because it's just going to work with any type of telescope, whereas some of the other methods have some trouble with some of the other types of telescope designs. For this video, I'm going to be using this refractor here to demonstrate setting everything up. So yeah. Now, if we're using a telescope, we should probably use a telescope mount to support the telescope and allow us to slew our telescope to the target that we actually want to image. The most important thing, I think, is going to be having a very sturdy mount. Any type of vibration in a non-sturdy mount is going to come through pretty hard, and you're not going to get very clear images if your mount is not sturdy. So it's okay if it's not a super high-end mount, just make sure that it's sturdy. If you don't have a motorized go-to tracking mount, then that means that you're gonna have to move your telescope to track the target in the night sky as the Earth rotates on its axis and as the sky appears to move. So just keep that in mind as far as adding more vibration into your setup. But it is still possible. The next thing that we're gonna need is a star diagonal, because I'm using a refractor. If you're using a Schmidt-Cassegrain or any other type of catadioptric telescope, then I would highly recommend also using a mirror star diagonal. But if you're using a reflector, you're not going to need one of these, because the placement of the focuser is in a place where it's actually not going to hurt your neck to be able to do this. This is a 2-inch diagonal, so this is going to go into my 2-inch focuser. And on this side, it can support eyepieces with 2 different barrel sizes. It can support eyepieces with 1 1/4 inch barrel sizes with this adapter here. And if I take off this adapter, I can use 2-inch eyepieces. The next thing that we're going to need is an eyepiece. Now, if your mount is not a motorized go-to tracking mount, I would highly recommend using 2 eyepieces. One eyepiece in the beginning to find your target and center up on it. That eyepiece should be one that has a longer focal length, which is going to give your setup a less magnified view, but it's also going to give you a brighter field of view as well. Now, once you do find your target and it's all centered up, I would go ahead and swap that eyepiece for an eyepiece that has a shorter focal length, which will give your setup a more magnified view, but it's also going to be dimmer. If you don't have 2 sets of eyepieces, or even if you do, I would highly recommend using a finder scope like this so you can find your target in the night sky. Now, there's a lot that I could get into about eyepieces, and really that could be an entire series of videos, so I'm not going to be covering that in great detail here, but I will link some material down below if you do have questions about eyepieces and just what they are all about in general. As you can see, I'm at the back of the telescope. So the first thing I'm going to do is add my mirror star diagonal to the setup, but I first need to remove the 1 1/4 inch visual back adapter. So there we go. Take my mirror star diagonal, put it through the back, secure the thumb screws. Next, I'm going to take my eyepiece here and I'm going to put it at the top of my diagonal. If you're using a reflector, make sure that you put your eyepiece into the top of your focuser. Next, let's go ahead and do a rough focus. If it's during the day, I recommend slewing your telescope and eyepiece to look at something off in the distance like a tree, look through the eyepiece and get everything really crispy and in focus. If it's not during the daytime, then I recommend slewing your telescope to a really bright object like Arcturus or Vega or Polaris. You could also slew your telescope to the edge of the moon just so you have some nice contrast, look through the eyepiece, and get everything really crisp and clear. Next, go ahead and slew your telescope to the target that you actually want to image if you're not already there already. And then once you are, go ahead and swap out your eyepiece for the other eyepiece that you actually wanted to image with if that's the path that you wanted to take. And go ahead and focus everything up. If you're having trouble locating your target in the night sky, then I recommend using something like Stellarium. It's a mobile app that you can download to your smartphone, and it will show you where the target is in the night sky based off of your location. In addition to using Stellarium, I would also recommend using a finder scope like you see here on the top of your telescope. Start off by looking for your target that you want to image with this first, and then go between your eyepiece and then the finder scope once you're starting to get kind of everything centered up. And then once you have everything centered up, go ahead and refocus your eyepiece to get everything all crisp and clear. At this point, we have focused the light path for our first focal plane within Afocal astrophotography. There are 2 focal planes within Afocal astrophotography. This is the first, so the light coming through the telescope to its focal plane is now focused through the eyepiece. Now what we need to do is take our camera with a camera lens, open up the camera app, or turn on your point and shoot camera, and then we're going to take our camera lens and move it over the eyepiece. Then, once we have everything in focus, we can go ahead and tap for auto exposure if you're using an iPhone, and then we can just press the capture button, and that's basically it for Afocal astrophotography. Now, if you really want to take your images to the next level, then I highly recommend getting this next piece of equipment. This is a universal smartphone adapter, and it makes things a lot easier because we put our smartphone in here and we clamp this around our eyepiece gently. The universal part of this adapter means that it's going to accommodate a large swath of smartphone devices. So I'm going to take this, put it over the eyepiece, and what's cool about this adapter in particular is that it has 3 axes that you can move your phone about. This axis moves it up and down, and then this other axis moves it left and right. And then this third axis moves it forward or backwards. So once you do have the best position for your setup, you can go ahead and press the capture button, or you could set a self timer, say of 3 seconds, which will also help to minimize vibration. Another cool thing that you can do now that you don't have to worry about holding your phone over here and worry about things getting in and out of focus and just the overall blurriness that holding something would introduce in general is that you can now manually adjust the exposure settings of your camera to get even better results. By exposure settings, I mean your ISO, your shutter speed, your focal ratio. If your smartphone's native camera app doesn't allow you to control the exposure settings manually, I highly recommend getting a third-party camera app to be able to do that. Also with an adapter, it makes it a lot easier to take short videos of the planets or the moon, which will help you to beat the atmospheric turbulence that is always present. So that about covers it. Our next connection method is called prime focus astrophotography, and this is where we use the telescope as our camera's primary lens. We're not going to be using an additional camera lens like we did before, nor are we using any eyepieces or a star diagonal in the imaging train. So because we're not using any of these additional optical components in our imaging train, this means that we're going to be using our telescope's native focal ratio of f/6.25. Additionally, because we're not going to be using an eyepiece, this means we're going to have a wider field of view, which means we're going to be using our telescope's native focal length of 500 millimeters. Do keep in mind though that your image field of view is also going to be dependent upon the sensor size that you have in your camera. Also, because we're not going to be using all of these additional optical components in our imaging train, this minimizes or reduces the opportunity for distortions or aberrations to occur in our images, which does improve our image quality. So we are essentially taking the light from the telescope from the primary mirror all the way to the main focal plane, which is the primary focal plane, and why we call this prime focus astrophotography. So not only do you have a more secure attachment to your camera, but you're also reducing distortions and other things that really are going to degrade your image quality. And for all these reasons, this is why prime focus astrophotography is the preferred way to connect a camera to a telescope. And it doesn't really matter if it's for DSOs or for planetary or for lunar, it's going to give you the best image quality overall. Here are a couple images from the prime focus method. The first thing you're going to need is a DSLR or mirrorless camera like this. You want to make sure that you aren't going to be using any additional lenses with it because we're going to be using, again, the telescope as our primary lens. So for our DSLR/mirrorless camera configuration, for it to be able to connect to the back of our telescope where the eyepiece or the mirror star diagonal would normally go, we're going to need 2 sets of adapters, usually. This is because DSLR and mirrorless cameras weren't made for connecting to telescopes, they were made to connect to camera lenses. So the first adapter that we're going to need is this T-ring right here. There are 2 sides to this T-ring with 2 different functions. So we have the telescope facing side, which is this side, and we also have the camera facing side, which is this side. The camera facing side has a bayonet style connection to it, and it's this side of the T-ring that's mounted to our camera body. By adding this T-ring here, it's going to allow us to connect to other adapters adapters, which will then allow us to connect to a telescope. But in some cases, we can just connect directly to a telescope with just this. Now, this next bit is really important about T-rings. T-rings are camera brand, camera make, and camera model specific, which means that you want to make sure that you get a T-ring that is made specifically for your camera brand and design. One reason for this is that camera brands use their own proprietary lens flange designs. Again, you just want to make sure that you get the correct T-ring for your specific camera, or else it's just not going to work, and I would not force it. Now, on the other side of the T-ring, the telescope facing side, this one right here, we have a female threaded adapter aperture right here. The most common is going to be M42 by 0.75. M42 in this case refers to the threaded diameter size in millimeters, but they can also come in different sizes like M48, M54. You'll see this a lot of times when you're using a camera with a full frame camera sensor. Now, the second part to that, the 0.75, refers to the thread pitch in millimeters. Something worth noting is that you might come across M42 adapters, for example, that have different pitch size threads. The common one that you might come across is 0.75, but you might also come across a 1mm thread pitch size. Now, this is important because depending on the adapter that you might thread with this T-ring, you want to make sure that you have the matching diameter size and the pitch size. Otherwise, your accessories won't work with it, or if you try to mount this directly to the back of your telescope or to a corrector, if it doesn't have the same pitch size and the same threaded diameter, it's just not going to work. All right, so the next adapter that we're going to need is this. These are the same types of adapters. I'm just going to show you in two different sizes, but essentially this is a T adapter. It's also sometimes called a prime focus nose piece adapter, and what this does is it allows us to insert the camera into the back of the focuser, and you take this side and you thread it into the female part of the T-ring. So you want to make sure that you get a barrel size that matches your focuser. So if you have a 1¼ inch focuser or accessory, then you want to use this dude here. But if you have a 2-inch focuser, you want to use this one here. So the first thing that I'm going to do is remove everything from the Afocal astrophotography method. Then I'm going to take my T-ring and I'm going to thread my 2-inch nose piece into the center. Then I can take my DSLR and remove the cover. It's going to look like this. Then I'm going to take my T-ring and I'm going to mount the T-ring onto the lens flange with the red dot here and the red dot here lined up. Then once you hear the click, you're good to go. It's very similar to when you're adding a camera lens to the camera. Now I'm going to remove the 1¼ inch visual back. Then I'm going to secure these thumb screws very securely so nothing falls out of place, because I think the last thing that any of us would ever want is to have our camera and accessories fall on the ground. Now, before we go further, I'm going to show you how to do this with a dedicated astronomy camera. This is the ZWO ASI 533 MC Pro one-shot color dedicated astronomy camera. It's a cooled camera, which means that it can keep the sensor cool while taking long exposures, which is really nice because this helps to reduce the amount of noise that you would otherwise get. So I'm not going to be adding any additional accessories with this part, but let me just show you what the nose piece looks like. I'll show you this with a 1¼ inch nose piece, but basically there are threads, and there you go. All right, moving back to the DSLR/mirrorless camera configuration. So I would turn my camera on and I could focus my telescope with the LCD screen on the back, which is really nice because oftentimes they will have optical zoom capabilities where you can get your star very pinpoint and small. If you don't have an LCD screen, you can just focus through the viewfinder. I also would highly recommend using a botaniv mask because those are really helpful to getting everything pinpoint and sharp. Now, not all telescopes require you to use a nose piece to attach them to. Sometimes if your telescope was actually made for astrophotography, you'll have threads on the back of your focuser where you can actually just thread the T-ring all the way onto the back of your telescope or on the top of your focuser. So this is a William Optics RedCat 51. It's an astrograph, meaning it's made for astrophotography. So there are threads on the back of this telescope where I can thread a camera or other accessories directly to it. So I'm going to remove this dust cap. The threads here are M48 threads. So I'm going to use this T-ring that has M48 threads as well. And then I'm going to thread this onto the back of the telescope. Then I'm going to take my camera here and mount it to the back of the T-ring, making sure I'm lining up the red dot with the arrow here. Now I'll show you how to do this with a dedicated astronomy camera. So for this, we're not going to need a T-ring. This is the ZWO ASI 533. It's the same camera that we showed earlier. If you aren't able to achieve focus with your camera and telescope setup or optical component like a corrector, then I highly recommend just looking into some additional adapters or fewer adapters. And by adapters, I just mean these here. I'm going to now thread it into the back, and it's pretty easy. This next bit is really important if you're using a reflector like a Dobsonian or Newtonian, but what you may have noticed is that you're still not able to achieve focus with a DSLR or mirrorless camera via the prime focus method, and this is going to be the case if your telescope wasn't made for astrophotography. This is because most Dobsonians and Newtonians were made for visual astronomy, and therefore the focal plane is set to accommodate eyepieces rather than camera sensors. What this basically means is that the camera sensor just can't get close enough to the mirror to be able to get a focused image. There just isn't enough inward travel to get your camera sensor close enough to the focal plane. So there are a couple solutions worth looking into. You could get a low profile T-ring, which will help to get your camera sensor closer to the focal plane. Also something to look into, some Dobsonians or Newtonians will have adapters in the focuser that you can remove. And if this is the case and you're also using a low profile T-ring, then you might just be able to attach the T-ring directly to the focuser and you might be able to get the camera sensor close enough. Our next method for connecting a camera to a telescope is called negative projection astrophotography. And this is where we use an optical component in our imaging train called a Barlow lens. And a Barlow lens is a type of image amplifier that's going to increase the focal length of our setup, and it's also going to increase the magnification artificially. By adding a Barlow lens between the telescope's focal plane and the camera sensor, the negative lens inside of the Barlow instrument is going to diverge the light and then shifts that light to converge at a new focal plane that is further back than where it would be normally without it. This increase in focal length and extended focal plane can oftentimes remedy the issue that we saw with reflectors when trying to pair them with DSLRs using the prime focus method, where we just weren't able to achieve focus because the camera sensor just sits too far back from the telescope's focal plane. This is just one use case for using a Barlow in your imaging setup, and they're not exclusive to reflectors either. You can use a Barlow lens in any type of telescope that you have where you want to increase the focal length and therefore increase the magnified view, which makes them great for imaging the planets and the lunar surface as well as the sun. So here's everything that you're going to need. The first thing that we're going to need for negative projection is, of course, a Barlow lens. Now, this is not a Barlow lens, it's a PowerMate, which is a type of image amplifier, but I no longer have my Barlow lens, so we're going to pretend that this is a Barlow lens, because if we didn't, then that would not be good, because Barlow lenses are a little bit different than PowerMates. So again, we're going to pretend this is a Barlow lens. All right, so when it comes to Barlow lenses, they do come in different sizes, and they'll also come with different barrel sizes as well, but a common size is 1 1/4 inch like you see here, and here's where you would connect your camera with a 1 1/4 inch nose piece. Barlows also come in a variety of different magnifications, anywhere from 1.5x all the way up to 5x, but more commonly up to 3x. In theory, when you use a 2x Barlow lens with a telescope with 1,000 millimeters of focal length, that's going to double your effective focal length to 2,000 millimeters. It would be the same if you were using a 3x Barlow with the same telescope. That would give you 3,000 millimeters. I do want to note that depending upon the positioning of where the Barlow is in the focuser of your telescope, as well as the position or distance from the Barlow lens to your camera sensor, all of these factors are going to impact the magnification and the overall effect to your focal length and magnification of your field of view. So that's just something to keep in mind. You might have more or less magnification depending on all of those placements. So if you do want the specified magnification that is listed on the device, I highly recommend making sure that you place your Barlow and your camera at the correct working distances. Now, if we are increasing the focal length, that means we are also going to be changing the focal ratio. So for our 1000mm telescope with our 2x Barlow lens, if the telescope has a native focal ratio of f8 and we add that 2x Barlow to it, this means that we're going to now have slower optics at f16. So it's doubled the f ratio. So it's slowed down the optics, which will make the overall image dimmer, which is fine if you're imaging the planets or the moon or the sun. It's less okay for imaging DSOs. There are edge cases for imaging deep space objects with a Barlow, but it's less common. Now you're also going to need a telescope, of course, and something that I would recommend, especially if you are imaging the planets, is getting a telescope with a larger aperture. This is going to help resolve the very small details for planetary imaging. It's not necessarily required, but if you do want to use a smaller sized aperture telescope, go for it. If you are going to be using a reflector or catadioptric design telescope, I highly recommend making sure that you have collimated your optics before your imaging session so you can get the best performance out of your telescope. Along with a well collimated telescope, if you have a design telescope that needs it, I would highly recommend using a telescope mount that is very sturdy, and ideally one that actually can track the object in the night sky without you having to touch it at all. It's not impossible to use a non-motorized tracking mount for this, but I would highly recommend using one. Every bit of shake is just going to cause so much blurriness in your image. Next, we're going to need cameras with the corresponding camera adapters. So for our DSLR/mirrorless camera configuration, we are going to need, of course, a DSLR or mirrorless camera, and we're also going to need the T-ring for that corresponding camera, and we're also going to need a 1 1/4 inch nose piece, because this 1 1/4 inch nose piece is going in the back of the Barlow. For our planetary camera, we're also going to need this 1 1/4 inch barrel nose piece because it's going to thread here, and we're also going to be putting it into the 1 1/4 inch opening of the Barlow. If you are going to be using a planetary camera, you of course are going to need some sort of acquisition software and a laptop or a tablet, and you're also going to need your power and anything else. So some acquisition software that I can recommend: Firecapture or SharpCap on a laptop, or ASI Studio. You could also get an ASI Air, where you're going to need to use a tablet or a smartphone for the screen interface. Now, I'm going to touch on planetary cameras a little bit more here. So if you aren't familiar, planetary cameras have much smaller sensors than something like a DSLR or mirrorless camera would have, and they have much smaller pixels, which is going to be really great for imaging the planets, for example. Your sensor size, just like we saw before, will inform your field of view. So if you're using a very small sensor, this is going to give you a much more magnified field of view, versus if you're using a full frame camera, which is going to be a much larger field of view. Which camera and telescope and Barlow you should use in combination with one another comes down to what your atmospheric seeing conditions are for your location that you're going to be imaging at. It also comes down to how well your mount is tracking. Any sort of tracking errors is also going to impede the performance of your overall imaging setup, but it also comes down to the overall resolution and sampling of your setup. So the right combination of telescope optics, as well as your camera's pixel size, as well as the Barlow that you're using and the focal ratio that it ends up getting. So I'm going to link a video down below by Dylan O'Donnell, who covers this topic incredibly well, especially for planetary imaging. So please go check it out, because it's going to be very helpful if you want to do planetary imaging. Starting off with our DSLR/mirrorless configuration, here we have the DSLR. I'm going to remove the dust cap. We are, of course, going to add the T-ring back onto the lens mount, as so. Then we're going to take our 1 1/4 inch nose piece and thread it back into the T-ring. Next, take your Barlow lens, or in my case, we're going to be using this 2.5x PowerMate. So anyways, again, let's pretend that this is a 2x Barlow. So I'm going to remove the dust cap. This PowerMate/Barlow has an opening that can take 1 1/4 inch nose pieces, which is good because that's what we have. Now I can insert the nose piece into the Barlow. And there are compression rings inside of this PowerMate/Barlow lens, and I can take this thumb screw, tighten everything up, then remove this, remove the 1 1/4 inch dust cap, and insert this into the back. As so. Now, your image is going to be dimmer than what you saw before, so I do recommend increasing your DSLR or mirrorless camera's ISO so that you can actually see what you're trying to look for and while you're imaging. Now I'm going to show you the planetary camera. Here's the planetary camera. What we're going to do is going to be very similar to what we saw before. So I'm going to remove the DSLR, remove the weird lens that comes with the planetary camera, add a 1 1/4 inch nose piece. At this point, I would add in my 1 1/4 inch threaded filter. Most planetary cameras will require some sort of filter to function well, at least, but maybe not all of them. I'm not familiar with like every single planetary camera, but yeah, now would be the time you would want to add your UV IR cut filter as an example, or your CH4 filter to the nose piece. And then once you do, you can just insert it in like you did before. And instead of increasing the ISO, you would increase the gain, but I'm sure if you're used to using a planetary camera, you would know that you use gain instead of ISO. Now, maybe you don't have a Barlow lens and you still need some sort of way to use your DSLR or mirrorless camera with your reflector telescope that wasn't made for astrophotography. Well, this next method and our fourth method and our last method is a great solution for you. Alas, we have finally made it to our final and fourth connection method, which, if you didn't read from the slide before this, is eyepiece projection. But what you may have not known is that sometimes it's called positive projection. And with eyepiece projection, or positive projection, this is where we use an eyepiece connected directly to the camera body to take photos or videos. Through this connection method, it's going to create a very magnified view, which is really great for taking photos of the lunar surface or of the planets. So here's everything that you'll actually really need. So for positive projection astrophotography, we are going to need a couple of different things. We're going to need a DSLR/mirrorless camera, or if you're going to be using a dedicated astronomy camera, you could also use one of those too. But for this demonstration, I'm just going to be showing the DSLR because it's very similar to what we saw before with the negative projection astro. So we have my DSLR here. You're of course going to need your T-ring, and you're also going to need an adapter that looks like this. It does come with a nose piece adapter here, so let me just take that off. So as you can see, there are threads up here, and we're gonna do that. And we of course need an eyepiece that will fit into the extension tube. The first thing that we're going to do is we're going to add the eyepiece into the extension tube. Obviously remove any of the dust caps. Voila. But there's kind of an issue with the rubber cup there. It's going to get in the way of the DSLR, so I'm going to remove that first. Most of these will just come off very easily, so yeah. Now, cool. Now we can just make sure that our eyepiece is secured with the little thumb screw. So let's take our DSLR, but we're going to remove the nose piece. So we should only have the T-ring attached. Then we can attach everything together. And I of course already have my nose barrel on there, so I'm just going to thread it into the visual back, but of course removing the dust cap. And that's basically it. So you just want to make sure that the connection method here is as straight and as sturdy as possible. The real main issue with eyepiece projection is getting any sort of wobbliness in your kind of adapter train. That's not going to be good because the light's going to get all bent and it's just going to make the image less good. Eyepiece projection isn't the most common way to attach a camera to a telescope, but I think it's really helpful just knowing all of these different ways so that you can kind of figure out what works best for you and what you want to get out of your imaging session. So that about covers it for this video. If you've made it to this point, just thanks so much. I hope you learned something, and I'm curious to know what methods you've used and what kind of successes you've had. And if you found this video helpful, please consider giving it some thumbs up and becoming a subscriber. If you're not already a subscriber, but if you are, thank you so much. And if you just became one, thank you so much. And also consider becoming a patron. It really does help support this channel. But really, as always, I just appreciate everybody's support, and I just hope you guys found this video helpful. Let me know down in the comments what else you guys would like to see.